Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 16, 2025, just yesterday. It introduces an adaptive test time search that raises imaginative video performance, hitting 57.11% imagery QA on LDT bench versus 48.28% for the baseline, an 8.83% gain, and about 83.48% on V-bench versus 78.53%. The paper is titled, ImagerySearch, Adaptive Test Time Search for Video Generation Beyond Semantic Dependency Constraints, and the results are really impressive. It adapts both search space and reward using prompt semantic distance, and debuts LDT bench with two 839 concept pairs plus automated evaluation. Also, the authors share the GitHub repo. You'll find a detailed README summarizing imagery search, method diagrams, an overview of the LDT bench prompts and metrics, and evaluation leaderboards, plus an assets folder. Code and the benchmark are marked as coming soon, so usage scripts and model weights aren't posted yet. Alright, Figure 1 explains why adaptive test time search is needed for imaginative prompts. The left column depicts how short-distance semantics are strong, while long-distance semantics are weak, which makes guidance during denoising unreliable. The top strip shows a normal prompt where a camel walks, and the baseline model stays coherent. The lower panel contrasts a long-distance prompt where a camel packs belongings, and common test time scaling methods drift or fragment motion. The bottom row highlights that ImagerySearch keeps the camel and the action consistent, with clear context-aware motion. Well, Figure 2 presents the full ImagerySearch loop that adapts both search space and reward to the prompt's semantic distance, which means how far apart the key concepts are in meaning. The diagram shows a text-to-video backbone fed alongside a constrained semantic scorer that estimates average semantic distance. At scheduled steps, the method samples multiple clips, scores them with a modular imagery reward, and keeps only a distance-controlled subset. The right panel illustrates candidate rows, where better clips are retained as generation proceeds. Alright, Figure 3 summarizes how LDT bench is built and why it stresses long-distance prompts. The top panels outline construction, which starts from meta-information extraction, then prompt generation with large models and human checks, and finally automatic evaluation. The lower left panel compares category coverage, showing a broader spread than prior sets. The lower right panel plots semantic distance, which means how far apart two concepts are in meaning, and the distribution shifts to longer ranges. So, Figure 3 set up the benchmark. Table 1 shows that the adaptive search leads across long-distance prompts. Imagery QA, an automatic question-answering score that checks objects, alignment, and anomalies, gives the method about 57%. The WAN 2.1 baseline records about 48%. Video T1 and Evo search trail as well, which signals stronger coherence and fewer visual mistakes on imaginative cases. Alright, Table 2 shows that the adaptive search delivers the strongest V-bench performance across metrics. The average column reaches about 83%, topping both general generators and test time scaling baselines. The subject consistency column is highest, which means the named subject stays recognizable across frames. Dynamic degree, meaning how vivid and coherent the motion looks, also improves alongside background stability and smooth motion. Together, these metrics indicate robust alignment on long-distance prompts. So, two takeaways stand out. Adaptive test time search that scales both exploration and reward by semantic distance reliably lifts imaginative video quality, and the new LDT bench gives a focused yardstick for long-distance prompts. The gains, roughly 57 versus 48% and 83 versus 79%, suggest better controllability for creative tools. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.